Okay, so we've spent a couple days now talking about graphing square root equations. Today we're going to move on to what are called cubic equations. Okay, so cubic equations mean, if we think about what it means for something to be cubed, cubed means raised to the third power. So cubic equations are going to be when solving an equation when x is raised to the third power, which we did a little bit of algebraically kind of at the very beginning of this quadratic equations unit. So just to refresh our memories about what it looks like to solve a quadratic by graphing, we're going to graph our equation and we're going to look for the x-intercepts. The x-intercepts are the places that it touches the x-axis, and those would represent the solution. So I will do that for this one now. Okay, so if we were to graph that equation, right, this equation here, right, y equals negative x squared plus 6x minus 5, it's going to look like the green graph that I have over here. We would say, where does this touch the x-axis? We'd say it touches the x-axis at 1 and 5. And we'd see, therefore, the solutions to my quadratic equation are x is equal to 1 and x is equal to 5. So just a little refresher there that when we solve a quadratic by graphing, we graph the equation, we look for the x-intercepts. The x-intercepts represent the solutions or the roots or the zeros. And that's going to be no different with the cubic. So we want to know when this equation will be, what values of x will make this true, right? X cubed plus 1 is equal to 0. Now, with any equation, the power, the largest power, tells us how many roots or solutions we can have. Doesn't mean how many we will have. We can have. Think about a quadratic equation. A quadratic equation most times has two solutions. If we have a perfect square trinomial, then it has one, and if we have something that's not factorable with the negative inside the radical, it's got no solution, right? So it can have up to that many. So we'd expect up to 3, but that doesn't mean we'll always get 3 solutions. In this case, we won't. So we're going to graph this equation, and we're going to look for the x-intercepts. So I'm going to fill out my table, starting with negative 2 to positive 2, but what we're going to see is a lot of the times that's not going to really be sufficient here. So let's see what this one looks like. Okay, so I've got negative 2, negative 7. I've got negative 1, 0. I've got 0, 1. I've got 1, 2. And I've got 2, 9. And again, guys, we're going to mostly be leaning on your calculators for this. For those of us who, you're at an apartment that doesn't have your calculator, you lost it or whatever, you can use the Desmos app. You can use, there's tons of graphing calculators app. Just Google, graphing calculator app. Because we really want to see what the graph looks like. In other words, if I didn't know any better, I may be graphing it like this. Line with a different slope, and another part of that line, right? But when we look at the graph, that's not what it actually looks like. It's curved, right? We realize that this part here is going to be curved. So it's going to be more like this. All right, which may be kind of a subtle difference, but it is a difference. Again, we're not just using a ruler and doing that, and that. We're actually making it curved so that it looks like that. And again, right, what we want to do is we want to look at this using our graphing calculator, and that's going to help us actually draw it. Because a lot of the times, as we're going to see, the points themselves don't necessarily help us with the graph so much. So we see that this only has one solution. And the solution is that x is equal to negative 1. Because let's think about this. In order for x cubed plus 1 to be 0, x cubed has to be negative 1, because negative 1 plus 1 is 0. Well, what's the only way that x cubed can be equal to 1? If x itself is negative 1. I said 1, I meant negative 1. If x itself is negative 1, right? If x is 1, we get 1 cubed is 1 plus 1 is 2, not 0. If x is anything bigger than that, this ends up being positive. If it's anything smaller, then your answer ends up being negative. So this is an example of a cubic equation with one solution. And this is how we can find that solution, by graphing the equation and finding the x-intercept. Okay, let's do the same thing here, right? X cubed minus x is equal to 0. So we're going to put that in y equals x cubed minus x. And again, you're putting this in your calculator. And let's take a look at what this is going to look like now. Okay, so let's plot these points and let's see how we know that this is really going to be kind of incomplete here. Well, I really don't have, right now, I don't have a good way to graph this, right? It looks to me as if it goes like that, and then over, and then up, and then it gets steeper again. or actually technically it'd be flatter and then steeper. But that's not what the graph looks like. So one thing you can do is you can look at the graph, plot the points, and then you could attempt to kind of mimic it, right? Some of you guys, when we did quadratics, were doing that in class. You were just literally drawing random quadratics in space. That's not what we're doing. But now that we've got some of the points, we can use the calculator as a guide. Now, that's not really the best thing to do. The best thing to do is to fill in some of the values that we're missing. Obviously, the most important one is this one that's right here, right? -half. So this requires us to change our table setup. So go to second function window, table setup, scroll to the second line down, and it should be table setup 1, change it to 0.5. So when I use -1/2, I end up with +3/8. Well, that makes a big difference, and it's going to be kind of subtle on my graph, but it ends up there. I want to say, well, I probably then should find out what happens after that on the positive side. So on +1/2, we get -3/8. Which is going to be down here. Well, that's going to make a big difference with how I graph it now, right? I know my graph has to come up a bit. It's going to kind of swoop up over here, come down a bit, dip, and then roll back up here and get steep. I don't remember if I'm guilty of this. I probably am, right? I always do that the first time. I forget to label for some reason, right? We've been out of school for a while, and I get a little rusty on this, just like you guys do. So we get y equals x cubed minus x. That's really what your graph should look like, and that will look a lot closer when you look in your calculator than just going up and then over and then like this and then like that, which is not at all what it looks like. We'd still get our solutions, I guess, but your graph is going to look pretty poor. Right, so based on my table, I think I know what my solutions are. And let's confirm that with my graph, right? So there's two places that this touches the x-axis. One is that it touches at -1, and the other is that it touches at 0. So if I sub in -1, -1 cubed is -1, minus -1 becomes plus +1 equals 0, so that will check. And if I use 0, I get 0 cubed is 0, minus 0 is 0, so that will check. So both of these roots will check. So what did we see so far? We had a cubic equation with one solution. We had a cubic equation with two solutions. And eventually, we may not see it with the next one, but eventually we'll get 2, 3 solutions. So let's do one more together. So again, guys, let's start to fill in our table, and then let's see what we need to do from there. So let's see what we can do with this one. We have a vast range of values here. So obviously I'm not going to be able to graph all of these, right? So I'm going to attempt to graph this equation. So that's what I put in my calculator, x cubed minus 4x squared. And I've got -1, -5. I've got the origin. I've got 1, -3. I've got 2, -8. 3, -9, 4, we come up to 0, and then 5 all the way up there to 25. So what's happening here? Well, if you look at your graph, because this is way too many fractional values, I think, for me to want to plot. If you look at the graph, we see that it comes up, it dips down, comes down here, and then kind of rips back up higher over there like that. So that's my graph. Now we're going to say, well, where are my zeros, right? And if I look at my table, I've got them. And if I look at my graph, I've got them. So my solution should be 0 and 4. And if I go back to check, I get 0 minus 0 is 0. And if I check 4, I get 64 minus 64 is 0. So certainly it will check. Now, tomorrow we'll talk about doing this algebraically, right? Graphing is not necessarily the most efficient method. It's the method we use if we're asked to. So we'll take a second look at this tomorrow, and we'll see what happens if we want to solve these algebraically. So here's your now try. So what you would do is pause, and then I'll start to fill it in. This is one where we will see all 3 solutions. So here's one, guys, where, if you're putting this equation into your calculator, you're looking at a table, and you're going to see on that table -1, 0, 0, 0, 1, 0. And you'd be like, how am I going to make this graph, right? And obviously, if you look at the graph, you're going to see it, But really, you'd want to include the rest of the points. If you were doing it on a Regents and you only had the integral points, and now you're going up and doing all this stuff, person scoring is going to be a little bit confused. And I realized I did it with the last one. That's because that was a kind of a strange one that did have a lot of kind of twists and turns down on the negative side. But for something like this, you would want to list the halves, which is what I've got listed here. So let's see if we can figure this out now. So -2, -12 obviously is going to be off my graph. So I've got -1, 0. I've got -1/2, 3/4. I've got 0, 0. I've got half, -3/4. I've got 1, 0, and I'm going to put these down as like a little guide. So I know that I'm coming up all the way from the bottom, looping up, looping down, and then popping, I don't like that, popping all the way up here, and getting very steep, obviously, on top. All right, so where do we see some solutions? Well, we saw them already on the table, but now we should see them on the graph as well. So we've got x is equal to -1, and x is equal to 0, and x is equal to +1. So if I sub in -1 here, I get -1 cubed is -1 times 2 is -2. -2 times -1 is +2, so +2 is 0. And then if I sub in 0, I get 0 minus 0 is 0. And if I sub in 1, I get 2 minus 2 is 0. So they will all certainly check. And homework, you're going to solve these 2 by graphing. So I should see 2 different graphs. If you do them on the same graph, it would be a disaster, it'd be a big mess. So you're going to make a graph and a table, right? So I know where you got the values from. Graph and table with the first one. Tell me what the solutions are. You don't have to write a sentence. Solution set is fine. And number 2, a second graph, a second table, and your solutions. As always, guys, any questions, just reach out to me and we'll have a discussion about it.